Hi everyone, welcome to lecture 27 of your electric circuit class. And lecture 27 is about nodal, loop, and superposition. The objectives of this lecture: the first one, use nodal analysis to solve for voltages and currents in AC circuits. The second objective is to use loop analysis to solve for voltages and currents in AC circuits. And the third objective is to use superposition theorem to solve for voltages and currents in AC circuits. These are our objectives for this lecture. So we will start with nodal analysis. I believe by now you should be able to apply nodal analysis in DC circuits. We are going to do exactly the same thing, and everything covered in DC circuits will be applicable to AC circuits, except the fact that we are dealing with complex numbers. So the first thing that, as before, you need to assign nodes, and we have in the circuit one reference node where the V is equal to 0 at that reference node. And make sure that when you write a nodal equation in each nodal equation, each term is an electric current term. And then if we have only a voltage source between two nodes, that means that is a supernode. So let us go over an example here to show you, let's say, the nodal analysis technique. We would like to find V naught which is a phasor in the circuit, and our circuit is plus minus. This is a 12 with angle 0 volts. This here is 6 minus J1. Three, and this is J2. So this is of course a 3 ohm, and this over here is J2 ohm. And then we have at this side here 4, and we have J6 ohm, and this is where we need to find V naught across this impedance. Sometimes that impedance is instead of that we draw it, for example, like this, and let's say that this is here 4 and this is J6. We can represent that as this element here, and we will say 4 plus J6 as one, let's say, component. Or if we have, for example, the capacitance, which is like this 6 minus J1, we can represent this as an impedance, and we will put a 6 minus J1 ohm. That is the same thing. So now the first step here is to assign the nodes. So we will assign a node here, we call it V1, and this is our reference here. So we will write at node 1. At node 1 we have V1 minus 12 with angle 0 divided by 3 plus J2 plus V1 over 6 minus J1 plus V1 over 4 plus J6, that is equal to 0. So we express the current in this branch, the current in this branch, and the current in that branch. So now if you look at this expression, I am sure that you will feel it is so complicated because we do have complex numbers and we have also fractions. So the best way is to divide each term by that, let's say, by its denominator. So over here we can say that simplify by dividing each term by its denominator. So we get, first, if you look at this here, I have V1 minus 12 with angle 0 divided by 3 plus J2. So V1 here, the coefficient of V1 is 1. So then we will have 1 divided by 3 plus J2. So let me simplify this one here so you will know what we are talking about. So I have 1 divided by 3 plus J2, that is multiplied by V1, minus 12 with angle 0 divided by 3 plus J2, plus 1 divided by 6 minus J1, that is V1, plus 1 divided by 4 plus J6, V1 is equal to 0. So I am going to do the math for this one here. 1 divided by 3 plus J2, that will be 0.231 minus J 0.154. That is multiplied by V1. Now the second term over here, I have a 12 with angle 0, which means that is really 12 since there is no angle, divided by 3 plus J2. So 12 divided by 3 plus J2, we are going to get 2.77. plus J 1.84. So 12 divided by 3 plus J2, it will be 2.77 minus J 1.84. But I have a negative over here, then we will end up with a plus J 1.84. Plus, so this is the second term here, right? Plus, I have 1 over 6 minus J1. That will come out to be 0.162 plus J 0.027, and that is times V1. Then we have the last term over here, which is 1 divided by 4 plus J6. That will come out to be 0.077 minus J 0.12 V1, and that is equal to 0. So now what we will do, we will collect the terms. Collect terms. So for example, if you look at V1 here multiplied by that complex number, and V1 here multiplied by another complex number, and V1 here multiplied by a different complex numbers. So usually that what we do here when we collect terms, we will add the real parts together and the imaginary parts together. So when we do that, we are gonna get 0.47 for the real part and minus J 0.247 for the imaginary part multiplied by V1. That is equal to this value here, because we are gonna get it to the other side, and to the other side that will become 2.77 minus J 1.84. So when I am putting this as a term, I can put it really the parentheses here. So this is here and here, or maybe no need for the parentheses, so you will not be confused. So 12 with angle 0 divided by 3 plus J2. Since we have a negative sign here, it will end up with negative 2.77 plus J 1.84. So now negative 2.77 plus J 1.84, when we move it to the other side, we need to flip the sign of each term. So the negative 2.77 becomes 2.77 positive, and the positive J 1.84 came out to be negative J 1.84. So from this, the only unknown is V1. So our V1 is equal to 2.77 minus J 1.84 divided by 0.47 minus J 0.247. And in this case, that is equal to 6.23 minus J 0.64 volts. However, if you look at this, that is in rectangular form. Always voltages and currents should be expressed at the end in polar form. So current and voltages, here I can write that here. Currents and voltages must be expressed in polar form. The reason behind that, because we like to know the level of current or voltage, which means we need the magnitude, and to know the level of current or voltage, which is the magnitude, and the phase angle. That's why it has to be in polar form. Okay, So now V1, I have it in rectangular form. We can convert that to polar form, and when we convert it to polar form, that will be 6.26 with angle negative 5.87 degrees, and that is volts. So if we look at our circuit here, the question is asking us to find V naught. So if you look at this V naught here, it is really it is the voltage across the element, which is this element, and this element is the only element between this node and the reference. That means really V naught is equal to V1. So we can say V naught is equal to V1, and that is equal to 6.26 with angle negative 5.87 volts. So let us go over another example here just to show you more, let's say, cases. We would like to find, excuse me, we would like to find V naught in the circuit. Find V naught in the circuit. And our circuit look like this. This is where Ix is flowing. This is 2 ohm, 4 ohm, J2, 6, and this is where we need to find V naught, negative J2, J2. The current source here is for Ix, and our voltage here is 24 with angle 0 volts. So our solution here, first of all, that our reference node is here. Then we will assign nodes. So I am gonna assign this here as V1, this node as V2, and this node as V3. So if you look at this node, that is the same as V3. So we can write at node 1. So if you look at node 1, there is a voltage source between node 1 and the reference. That means our V1 is equal to 24 with angle 0. And this is our first equation. Now at node 2. At node 2 we have V2 minus V1 over J2 plus V2 over negative J2 plus V2 minus V3 over 6, that is equal to 0. Now how we can simplify that? As what we said, that just divide each term by its denominator. So now if you look at this here, the first one, it is divided by J2. So if I bring the J to the top, it will become negative J, right? And then we multiply by half, right? Because 1 V2 divided by 2 is half V2. So this is what we will do. So that will be negative J 0.5 V2 plus J 0.5 V1. The reason behind that, because we have a negative here, and when we bring that J to the top, it will become negative J, and I have a negative, it will become positive. And then 1 divided by 2 is half, plus J 0.5 V2 plus 1 divided by 6, that is 0.167 V2 minus 0.167 V3 is equal to 0. Now we collect terms, so we will have J 0.5 V1 plus 0.167 V2 minus 0.167 V3, and that is equal to 0. And this is our second equation. Now we need to write at node 3. At node 3, we'll have V3 minus V2 divided by 6 plus V3 divided by J2 plus V3 divided by 4 plus V3 divided by 2 minus 4ix, that is equal to 0. So when we divide each term by its denominator, we are going to get 0.167 V3 minus 0.167 V2 minus J 0.5 V3 plus 0.25 V3 plus 0.5 V3 minus 4ix is equal to 0. Now we will collect the terms. We will get negative 0.167 V2 plus 0.917 minus J 0.5 V3 minus 4ix is equal to 0. And this is our third equation. So now we have 3 equations, but we have 4 unknowns because of the dependent source. So we have to write an equation for ix. So our ix in this case is equal to V3 over 4. Divided by 4. And from that, we can say V3 minus 4ix is equal to 0. And this is our fourth equation. So now we have to put those in matrix form. So we will have 1 for V1, 0 for V2, 0 for V3, and 0 for ix. And that is 24 with angle 0. Second equation, J 0.5, 0.167, negative 0.167, and 0. The third equation, we have 0 minus 0.167, and the third term here, 0.917 minus J 0.5, and then negative 4. Then we will have 0, 0, 1, and negative 4. And these here are zeros. So now when we solve, we are going to get V1 is equal to 24 with angle 0, V2 19.2 minus J 62.25. Our V3 came out to be 19.2 plus J 9.6 volts. Our Ix came out to be 4.8 plus J 2.4 volts. So what we are looking for is V naught. So V naught, if you look at your circuit, that is equal to V2 minus V3. So that is equal to 19.2 minus J 62.25 minus the V3, which is 19.2 plus J 9.6. And the answer here is negative J 71.85 volts. However, this is in rectangular form, so it doesn't have a real part, only imaginary part. So the negative J is really negative 90 degrees. So we can convert that rectangular form quantity to a polar form, and that will be 71.85 with angle negative 90 degrees volts. And this is what our V naught is. So now we can go to loop analysis. In loop analysis, we said that first you need to assign the loop currents or the loops, whether that you go counterclockwise or clockwise, that doesn't matter, or you can mix them. And in each loop equation, each term must be a voltage term, because you cannot mix voltages and currents in the same equation. You can't do that. So let us go over an example here. Suppose that we would like to find the voltage V naught in the circuit, and our circuit look like this. So this is negative J5 ohm. This is 16 with angle 0 volt. This over here is 4 plus J8 ohm. This over here is 2 ohm, and we would like to find our V naught here. This current is 6 with angle 0 ampere, and this is a voltage source, and our value is 2ix, and then we have over here negative J4 ohm, and over here also we have 2 ohm. And our Ix is going up here. That is the controlling variable. So we said that the first step is to assign nodes. So we are gonna call this as I1, and all of those are phasors, okay? This over here is I2, and over here we can go with I3. So we will go with loop 1. If you look at loop 1, there is this current source here. It is between loop 1 and loop 3. That means that is a super mesh. Then we can write an equation for both loops. So loops 1 and 3. The first equation is I1 minus I3 is equal to 6 with angle 0. And this is our first equation. The second equation that we can write minus J5 I1 minus 16 with angle 0 plus 4 plus J8 I3 plus 2I3 minus J4 I3 minus I2 plus 2ix is equal to 0. So you will not be, let's say, confused regarding this loop. So we started here. So we are going this way, this way, this way, right? Where now? We go over here, right? We go over here, we go over here, and we go back. This is both loops, okay? These are the both loops that we went with. So now we will collect terms. So we will have minus J5 I1 plus J4 I2 plus 6 plus J4 I3 plus 2ix, that is equal to 16 with angle 0. And this is our second equation. So now we are gonna go with loop 2. For loop 2, that is minus 2 ix minus J4 times I2 minus I3 plus 2I2 is equal to 0. Collect terms. We will have 2 minus J4 multiplied by I2 plus J4 I3 minus 2 Ix is equal to 0. And this is our third equation. So now we have 3 equations, but we have 4, 3 equations and we have 4 unknowns. So since we have a dependent source, then we can write our Ix. Our Ix is equal to I1, which means we can write I1 minus Ix is equal to 0. And this is our fourth equation. So now we have 4 equations into 4 unknowns, put them in a matrix form, and then solve. So we will have 1, 0, minus 1, and 0, minus J5, J4, 6 plus J4, 2, 0, 2 minus J4, J4 minus 2, 1, 0, 0 minus 1. That is multiplied by I1, I2, I3, and IX. And that is equal to 6, 16, 0, and 0. So when we solve, this is what we are gonna get. Our I1 is equal to 8.52 plus J 2.2 ampere. I2 3.72 plus J 4.6 ampere. I3 2.52 plus J 2.2 ampere, and IX, that is 8.52 plus J 2.2 ampere. So our requirements here, it is V naught. So V naught is equal to 2 I3. So that is equal to times 2.52 plus J 2.2, and that is equal to 5.04 plus J 4.4 volts. However, we said that voltage and current should be given in what? In polar form. So that will be 6.69 with angle 41.12 volts. And this is our answer for that voltage V naught. The third thing, that is the superposition. It is exactly the same as in DC. So we need to activate only one source at a time and solve for the required value. Repeat for the rest of sources, and then add all contribution. To get the final answer. When you turn off voltage source, you need to short it. When you need to turn off current source, you need to open it. Let us go over an example here. Suppose that we would like to find I naught in the circuit using superposition. And this is our circuit here. 12 with angle 0 volt, 5 ohm, negative J4 ohm, J8 ohm, 10 ohm, and we have a current source over here, and that is 2 with angle 0 ampere. And the current that we need to find is the current flowing in this 10 ohm resistor, I know. So when we are using superposition, we need to activate only one source at a time. So we will assume that let I naught 1 due to 12 with angle 0 volt source, and I naught 2 due to 2 with angle 0 ampere source. So now we will go with our first one. So due to 12 with angle 0 volt source. So our circuit will look like this. That is 5 minus J4, J8, (12 with angle 0 volt). This is 10 ohm, and this is I naught 1. And of course that the current source is here, so we opened it. So we have, if you look at our circuit here, we have a single loop. So we can solve for I naught 1 by saying that voltage divided by the total impedances. That is 5 minus J4 plus J8 plus 10. So in this case, that is equal to 12 with angle 0 divided by 15 plus J4. And the answer here is equal to 0.747 minus J.199 ampere. That is our I naught 1. So now, due to the current source, which is 2 with angle 0 ampere source, this is our circuit. This is 2 with angle 0 ampere. This is 5 ohm minus J4, J8, 10, and this is I naught 2. Now we have a voltage source here. To turn off that voltage source, we short it. So now we can use current division. Anyways, that you can use whatever that you like. Any analysis technique. You can go with loop analysis. You can go with nodal analysis, as long as you get the current I naught 2. So in my case here, I am using current division. So our I naught 2 is equal to, since we need to find the current because we have only 2 branches in parallel, since we need to find the current here, then I will take this resistor divided by the total, which is 5 minus J4 plus J8 plus 10 multiplied by the total current, which is 2 with angle 0. So this is equal to 5 divided by 15 plus J4 times 2 with angle 0, which is equal to 0.623 minus J 0.166 ampere. So now our total current, that will be I naught 1 plus I naught 2. So our I naught is equal to I naught 1 plus I naught 2. So I naught 1 came out to be 0.747 minus J 0.199. So we can write that down here. So that is 0.747 minus J 0.199 plus 0.623 minus J 0.166. And the total answer here is 1.369 minus J 0.365. However, we said that our final answer have to be in polar form. So this is equal to 1.417 with an angle of negative 14.93 degrees, and that is in ampere. So this is our final answer. So based on that, in this lecture, as long as you know how to use nodal, loop, and superposition theorem, you will be in great shape. Make sure that to turn off a voltage source, short it, and to turn off a current source, open it. Don't go the other way around. And over here is our homework for this lecture. 2 problems. And thank you for watching.